All right, today we are pulling back the curtain on something that is, quite literally, powering almost everything you do online. We're talking about the digital backbone of our world, databases. I mean, think about it. From your social media feed to your Netflix queue, what if I told you that underneath all that slick design, they're all built on the exact same fundamental concept? It's an idea that once you get it, well, it's going to change how you see the entire digital world.
Because really, at its heart, that's all a database is. Just picture the most organized, color-coded spreadsheet you can possibly imagine. Now make it way faster, a whole lot smarter, and give it the power to handle millions, even billions, of pieces of info without even breaking a sweat. That's a database.
Okay, so to really understand how these incredible systems work, we've got to learn their language. You can think of these next few terms as the basic grammar of tech. These are the absolute keys to unlocking the digital world. First up is the entity, and honestly, it's super simple. This is just the main thing we're collecting information about. So it could be a person in your contacts, a product on Amazon, a movie on Netflix, or a student in a school system. It's basically the noun of our data sentence.
So for every entity, we have attributes. These are just the specific details we want to save. So for that person entity, the attributes might be their name, their phone number, their email. For a product entity, it could be the price or how many are in stock. You get the idea.
And when you bring all those attributes together for just one single entity, well, now you've got a record. The easiest way to picture this is as a single row in that giant spreadsheet we were talking about. It's the complete file for that one specific person or that one product.
Now here's the really crucial part. How do we make sure every single record is unique and we can find it in a split second? That is the job of the primary key. It's a totally unique ID, kind of like a serial number or a student ID, that gets assigned to each and every record. This makes sure there are no duplicates, and it makes searching for stuff incredibly fast.
Okay, and here is where it all just clicks into place. Just look at this table. See that first column, ID? That's our primary key, a unique number for each person. Now, each row is a record. See, you've got all the info for one person, like Irfan. And the columns for name, mobile, and email, yep, those are the attributes. It's simple, it's clean, and it's perfectly organized.
So, now that we've got the language down, let's talk about how this hidden engine is working all around you every single day. Probably right there in your pocket. You know, this quote from Simon Lum at the BBC just nails it. When you're scrolling through a streaming app, what you see is this beautiful, seamless interface. But what's actually running the show underneath all of that? A massive database, just organizing everything into cells, rows, and columns.
And trust me, they are truly everywhere. Your social media profile, that's a record in a database. When you browse Shopify, you're searching a huge product database. Netflix's amazing recommendations, all powered by a database of your watch history. It even gets crazier. Something as complex as predicting flu outbreaks has been done by analyzing search data stored in Google's databases. So if we're trusting these systems with everything from our shopping habits to our health information, they have got to be reliable. And this brings us to a huge principle for anyone who designs databases: garbage in, garbage out. It's simple. If you put bad data into the system, you're going to get bad results out. So how do we stop that from happening?
We use two key checks: validation and verification. Now, they sound similar, but the difference is absolutely critical. Validation checks the format. For example, does this postal code have the right number of digits? Verification, on the other hand, checks the facts. Is that the correct postal code for that specific address? One's about structure, the other's about truth.
And the databases themselves enforce these rules automatically. A type check makes sure you can't enter your name in a phone number field. A length check makes sure your PIN is exactly 4 digits, not 3, not 5. And a presence check just makes sure you don't leave a required field blank. These simple little rules are the first line of defense for data quality.
But what happens when these systems that we depend on so completely just go wrong? To really understand the stakes, we have to look at what happens when the digital backbone actually breaks. So back in 2022, Canada's Rogers network had this massive outage. Now, to be clear, this was a network failure, not a database failure, but the lesson is universal for any critical system. One single flawed update created a single point of failure that took down essential services for millions of people. It's just a huge reminder that these principles of reliability matter everywhere.
So how do you prevent that kind of catastrophe? Well, you build for reliability right from the start. Instead of pushing an update out to everyone at once, you use staged rollouts. You test it on a small group first. You build in redundancy, which just means you have backup systems ready to take over in an instant if the main one fails. And of course, you have backups, so if the absolute worst happens, you can restore the data and get back online fast.
Okay, let's bring this all home. We've gone over the language, we've seen the applications, and we've talked about the risks. So what's the big picture? What's the main thing you should really remember from all this?
First, let's just lock in that core language one more time. Remember, every system is just organizing things, those are the entities, by their details, which are the attributes. Each complete row of details is a record, and that primary key is the unique ID that keeps the whole thing from becoming a total mess. That's the grammar of data.
And why does any of this matter? Because when you organize data this way, it becomes incredibly fast, super easy to search, and totally consistent. Databases really are the silent, invisible engine that organizes the chaos of the digital world, making modern life as we know it even possible. So, I'll leave you with this question to think about. Just take a look at the apps on your phone. Which one of them relies so heavily on its database that if it suddenly failed, your day, or maybe even your whole life, would just grind to a halt? When you figure that out, that's when you'll truly understand the power of the digital backbone.